We're going to talk about regulation and population growth. There are going to be many environmental factors that affect population growth, the first of which, or the first type we're going to talk about, are density-independent factors. These are going to have the same effect regardless of population densities. It's going to be things like drought and fire. No matter how many individuals are there, if it's one is the population, but if it's a small population or a large population, if there's a fire, everybody still dies or leaves. Density dependent factors are going to have a greater effect when population density is higher. And we're going to have a slide later that goes through 6 of these examples. So this is just a teaser. And with feedback regulation, we've talked about feedback regulation a lot throughout the year, but without negative feedback, our populations would never stop growing. And negative feedback here is going to be those density dependent factors. We're going to have 6 mechanisms of density dependent regulation. We're going to list all 6 and then come back and talk about them. Up first is competition, predation, toxic waste, intrinsic factors, territoriality, and disease. If you think about a farmer planting a field of crops, they're able to plant the crops really close to one another and still get a good yield and good success rate because they're adding fertilizer. There's actually not enough nutrients in the soil to plant them that closely, so to overcome or to compensate for that, they have to add fertilizer. Critters can compete for other resources as well, so don't think it's just space. Predation. If a predator catches too much prey, the prey population is going to decrease, and it's either going to, then the predator is either going to have to find a new prey population, or it's going to have to, or its population is going to decrease. There's an example in your book about the cutthroat fish switching species of aquatic larval insects that they eat every few days so that each of their prey populations can rebound. Toxic waste. A lot of times, if you stick, let's say you're sticking bacteria in a nutrient broth, it's like heaven for bacteria, and its population increases and increases and increases, and then you hit a point where the byproducts of all their metabolic reactions, which are toxic to them, end up killing them off, or at least holding their population levels down. Yeast works the same way. It's going to convert carbohydrates to ethanol in the process of making wine. And then the ethanol accumulates to toxic levels for the yeast. Next up are intrinsic factors. There we go. As population levels increase, your birth rate can decrease and death rate can increase because of aggressive interactions and hormonal changes that delay sexual maturation and depress the immune system in your population. With territoriality, space is definitely the resource here. It leads to competition. A lot of cats will spray their area to mark their territory. A lot of birds will peck at anything near their nest. And by having your own territory, you increase the likelihood of capturing enough food so that you can be successful in reproducing. And non-breeding individuals are actually that are actually in those territories non-breeding individuals is indicative that the territoriality is restricting population growth. Then we have disease. This can be like the flu or tuberculosis. The transmission rate is dependent on crowding. Anything that's spread through the air when an infected person coughs or sneezes would fit here. Then we have population dynamics. As population levels, changes in population levels, and this can be from year to year, place to place, and we can have stability and fluctuation. If you have something like harsh weather or cold, wet winters, they can actually weaken your mammals and reduce food availability. Some organisms have a very unpredictable population size. Some have very regular cycles. Small herbivorous mammals like voles and lemmings have cycles that are every 3 to 4 years. Some birds are like 9 to 11 years. And your classic example here is the snowshoe hare and lynx. And I'm going to assign you to read about that. Read that one example as your homework. Summarize it for me for the predation and sunspot activity. And then immigration, and metapopulations. When crowding occurs, immigration often increases. And metapopulations are numbers of local populations that are linked together. And you'll have these patchy available areas with unsuitable habitats around them, and so you'll have a metapopulation. And look for a figure in the book there. So you have homework here. Look for the figure there, and then that's the end.